Assume ZESCO is a sole provider of electricity in Zambia. To meet the monthly demand for electricity in the country, which is given by the inverse demand function, P equals 1000 minus 0.5 Q. The utility company has set up two electric generating facilities. Q1 kilowatts are produced at Kariba Dam and Q2 kilowatts are produced at Victoria Falls. So Q equals Q1 plus Q2. The cost of producing electricity at each facility are given by the function C1Q1, it is, C2Q2, it is, respectively. Determine the profit maximizing amounts of electricity to produce at the two facilities. Number 2, the optimal price. Number 3, the company's utility profits. Okay, so here you are given a situation where you have two cost functions. Okay, in this case, the cost functions are similar. All right. So this is how you deal with such type of questions. Okay. The first step, since they want the profit maximizing amount, step 1 first, get your total revenue. It hasn't been given to you. Remember, total revenue is price times quantity. Always remember this formula: price times quantity. Okay, so here our price, where you just see a P equals whatever, just take that as your price. Price is 1000 minus 0.5 Q. Okay, so with this shortcut method, okay, do not substitute this Q equals Q1 plus Q2 into this yet, or into the cost function yet. Okay, first you just deal with it like you're dealing with one cost function. Okay, just start like you're dealing with one, like you've got one cost function here. Okay, so Q times 1000, that is 1000 Q. Q times negative 0.5, you get negative 0.5 Q squared. Okay, so that's the first thing. Deal with total revenue first. Okay, we've got our total revenue function. Okay, number 2, get your marginal revenue function. Okay, so remember, marginal revenue is the derivative of total revenue, deriving the total revenue function with respect to Q. So if we derive 1000 Q, it becomes 1000. Comes 1000 minus, here you're going to say 2 times 0.5, that is 1. So we have 1 Q. Okay, and remember, you always subtract the power. 2 minus 1, that is 1. Okay, so basically our marginal revenue function is 1000 minus Q. Okay, do everything, you start just like you've got one cost function. Okay, get your total revenue, get your marginal revenue. Okay, the long cut method, where we see Q, we substitute it with Q1 plus Q2. Okay, but in this method here first, You tackle it like you're dealing with one cost. You've got one cost function. After you've got your marginal revenue, now you can come to your marginal cost. Okay, we've already got our total cost functions. Okay, and these cost functions are identical. So the marginal cost function for the first utility is the marginal cost function for the second utility. Okay, so number 3, get marginal cost. Okay, so we derive this 10,050. We will say the marginal cost function for facility 1. Just hold on, colleagues. Hello? You okay? I'm okay. Yeah, by the gate? Yeah, yeah, yeah. Okay, sure. Let me just pass a message. I'm coming. Just give me 2 minutes. Okay, so where were we on? Yeah. So we get the marginal cost function. Okay, so we're deriving this 10,050 plus 5q squared. Let me write it down. Okay. 10,050 plus 5q1 squared. So we're deriving this function. Okay, so since 10,050 doesn't have a q, it goes. Then remember, multiply the exponent 2 times 5, that is 10. Okay, subtract a 1 from the exponent. So it's 10q1 to the power 1. Okay, so the marginal cost for utility 1 is going to be the same as the marginal cost for utility 2. Okay, so it's also going to be 10q2 to the power 1. Okay, we've derived it. So the next thing that you need to do after you've got your marginal costs, okay, equate them. Okay, equate marginal cost 1 to marginal cost 2. Okay, you're going to see the reason why we're equating these marginal costs. Okay, so you say MC1 equals MC2. All right, so you're going to say 10q1 equals 10q2. If we divide both sides by 10, then eventually q1 equals q2. Okay, q1 equals q2. So the reason why we equated these two marginal costs is so that if you remember this equation they gave us here, Q equals Q1 plus Q2. All right, want to put this equation into one variable basic. Okay, so we can easily substitute. Okay, so this equation here, which we've been given, Q equals Q1 plus Q2, we can substitute this new identity we've got, that Q1 equals Q2, into this equation, which was given to us, Q equals Q1 plus Q2. Okay, this identity, you equate the marginal costs so that this identity you can substitute it in here. Okay, so if we want, we can substitute Q1 with Q2, or we can substitute Q2 with Q1, either way. So let's substitute Q2 with Q1. Okay, so according to our identity, we've been told Q1 equals to Q2. So this Q2 in this here, this Q2, we're replacing it with Q1. So that eventually Q equals 2Q1. Okay, colleagues? So that we can now equate one marginal cost function to the marginal revenue function. So we can find Q. We did all of this so that we can just equate one of these two to the marginal revenue function. Okay, that's why we first equated. When we got our identity here, we substituted it into the equation that was given to us in the question. This was given to us, Q equals Q1 plus Q2. So this identity we got when we equated the marginal costs, we bring it back into this equation. Okay. So now that we know 2Q equals 2Q1, we can now use this marginal cost function here and equate it to the marginal revenue. Okay. So remember, the point of profit maximization is where marginal revenue equals marginal cost. So we'll say MC1. Marginal revenue, we got our value for the marginal revenue, 1,000, was it marginal revenue? 1,000 minus Q. Which equals MC equals 10 Q1. Okay. So this Q with the marginal revenue, since we know that Q equals 2Q1, okay, we said Q equals 2Q1, so we can bring it in here. Okay, we substitute this Q here. So we get 1,000 to Q equals 2Q1, yes. Oh, our marginal revenue is 1,000 minus Q. What to put the minus sign here? 1,000 minus Q. Okay, so it becomes 1,000 minus 2Q1. Equals 10 Q1. Then we can solve for Q1. We can find the value for Q1. Okay, group like terms together, so it's going to be 1,000 equals 10 Q1 plus 2 Q1. And we have 1,000 equals 12 Q1. Get the value of Q1. We divide both sides by 1000. Colleagues, what is 1000 divided by Q1? Those with calculators. Anyone with a calculator? I don't have power here, so I can't see where my calculator is. And my phone is charging. Anyone with a calculator, 1000 divided by 12. 1000 divided by 12. Uh-huh. So is it a message or was it 83.33? Okay. 83.33, yes. This is a funny eight. Yes, 83.33. So Q1 equals 83.33. Okay. And if we remember our identity here from when we created marginal costs, okay, Q1 equals Q2. So if Q1 is 83.33, Q2 is 83.33. And since they are identical cost functions, okay, so you expect when you're tabulating quantity, they should be the same. Okay. So our value for Q, then, okay, you can either use the Q1 plus Q2, or remember Q equals 2Q1. Okay, either. Okay, so if we use the Q1 plus Q2, according to what was the question gave us, 83.33 plus 83.33. What is 83.33 plus 83.33? Okay, 166.67. Okay, we're going to, yes. Any questions, colleagues? I know it's kind of a long process, but any questions? So the key here is equate the marginal costs so that you can have an identity for Q1 and Q2. Okay. Once you have that identity for Q1 and Q2, you implement it into your given quantity equation here. With this one, Q equals Q1 plus Q2. Okay. So just know that, okay, so for me to simplify this equation here, I just have to equate my marginal costs so that I know what Q1, I can express Q1 in terms of Q2, okay? Or express Q2 in terms of Q1. That was the point of equating our marginal costs here, to equate either Q1 as an expression of Q2 or vice versa. Okay, so if that's the profit maximizing amount. Okay, 83.33 for is it Victoria? 83.33 for Kariba, 83.33 for Victoria Falls. Then in total, they have to produce 166.67. Okay. Optimal price, just substitute Q with 166.7 E. So for the optimal price, just say P equals 1000 minus 0.5 open brackets 166.67. Okay, so it's a 1000 minus 0.5 times 166.67. I believe it's 83.33 because 0.5 is it's like half. So 1000 minus 83.33, what do we get? 1000 minus 83.33, 916.67. That's the optimal price they need to charge. Then part 3, get the utility company's profits. Remember remember this formula. Profit is total revenue minus total cost. Okay. So total revenue, you bring in your revenue function. Revenue function was 1000 minus 0.5 Q squared. 1000 Q minus 0.5 Q squared minus total cost. We add these C1 Q1, C2 Q2. Okay. 10,050 plus 10,050. Let's see. Colleagues, are you about to get me? I don't know if my bundles are almost about to be depleted. Okay, let me get bundles. Can you get me? Are you able to get me? Are you able? Okay. My band was just finished there. Sorry about that. Yes. Just hold on. Hello? Yes, let's continue. So we're getting the profit with the just total revenue minus total cost. Okay. Let me just see if my board has reloaded. Let me just see if my board has reloaded. Okay. Then what has happened to the board? Okay, when getting the profit, okay, I think we did. Since the board is not showing, where did I get this? Never put. Okay, for getting the total profit, the company's profits here. Since we found Q, and we know what Q1 is, okay, so it just means Q, that 166.67, you bring it here in the total revenue function. Was the total yes, in the total revenue function, this one here, substitute it with 166.67, you get your total revenue. Then your cost functions, this 10,050 plus 5 Q1 squared, Q1 is 83.3, so you square it and you add. Even here, 1050 plus 5 Q2 squared, substitute 83.3 with Q2, you add. Once you get your total cost for C1 and C2, combine them together and you subtract from your revenue. Since the board is failing to think. But are we okay with that, colleagues? Once you found your Q, your Q1 and your Q2, your Q, just put it in your total revenue function. You get your total revenue. Ish, colleagues, sorry, the mic was unmuted. I was saying that my board is not showing. I have to restart it. So I was saying to get your your profit, okay, to get your profit, Q, substitute it with 166.67. In this total revenue function, make Q 166.67, you get your value of your total revenue. Then, for your total cost function, here where there's a Q1 squared, substitute it with 83.3, you get your total cost for facility 1. For facility 2, where there's Q2, substitute it with 83.3 and square it, get the total cost for facility 2. Then you add up those costs for facility 1 and facility 2, and you deduct from the total revenue to get the profit. Is that okay, colleagues? I'm having another class soon. We might have to do another session at. Is 22 hours okay if we do another session then?